Hello and welcome back. Today's section is section 2.1.1 Statement and Logical Connectives. So the first objective of today's class is to identify and negate simple statements. But to go ahead and do that, first let's talk about what is a statement. So as you can see, a statement is a sentence or a sentence or a mathematical expression that has a definite truth value. That is, it could be either true or it could be false, but it cannot be both at the same time. So again, keep in mind, it can either be true or it can be false, but it cannot be both at the same time. So let's take a look at the first example. Which of the following are the statements? Email provides a mean of communication. So is that true or false, or is it both? Email does provide mean of communication, so that is a statement. 12 plus 16 is equal to 18. That's a true, so that is a statement. Look over here. Look over here. That's a command. It's not a statement. So no, this is not. Orange is the best color. According to who? This is subjective. So this is also not a statement. An even number greater than 2 can be written as a sum of two prime numbers. Now, I'm not looking to write down all the even numbers. I'm not looking to write down all the prime numbers, but I'm just going to take a step back and see an even number greater than 2 can be written as sum of two prime numbers. Now, the question is this a statement or no? Remember that this could be either true or this could be false. So that means this is a statement. 3 times 5 is 25. False. So that is a statement. I am lying to you. I don't know if you're lying to me or no. So this is not a statement. Do you see that? Something that has a truth value is a statement. Let's go ahead and look at negation. Negation is simply opposite or negating something. So if something has a truth value of true, the negation of truth is false. Something is false, the negation is truth. Now, having said that, negation of a statement P is simply not P. Today is Sunday. Today is not Sunday. It's raining. It's not raining. See, so simply putting a not in front makes it a negation. So a false statement becomes true, a true statement becomes false. And how do you represent a negation? You either say not or you put something like this, which is called a tilde. So this is a notation for your negation. All right. Now let's go ahead and look at the examples. Form the negation of following sentences. 3 times 5 is 25. So I'm going to say 3 times 5 is not 25. The Eiffel Tower is not in London. The Eiffel Tower is in London. I will eat lunch today. I will not eat lunch today. Some of these are odd. Some of these are not odd. It's as simple as that. We're going to look into the logic of these. If P represents the statement, it's not true that sun rises in the west. Which of the following statements represents not P? Again, I'm going to go back and see it's not true. So P is telling me it's not true. So the negation of P should tell me that it's true, right? So it's the opposite. It's not true that the sun rises in the west. The sun rises in the west. Yeah, it is the opposite of this. So this could be my answer. Sun rises in the east. It is true that the sun does not rise in the west. It is true that sun rises in the west. So yes, sun rises in the west is the opposite of it's not true that sun rises in the west. And it is true that sun rises in the west is the opposite of sun not true rises in the west. So you have to be very, very careful. And when they ask you to apply everything that works, you might want to go ahead and take a look and apply everything that works. All right. Negation, very, very, very important. So when I say all are AB, then the opposite is there is not A that is not B. This is the way you negate some of the statements, and this is the standard way of doing it. If you want to write this down, I highly recommend you to do so. Some A are B. So the opposite of some A or B is that there exists at least one A that is B. So opposite of some, or the negation of some, is there exists at least a one. No A or B. All A are not B. It's just the negation. Some A are not B. Not all A or B. Okay? So the following this diagram kind of helps you to pick the right answer. All A are B, the opposite is some A are not B. So I highly recommend having this diagram on your note card when you're taking a test because it does help. We will do a couple of problems from the homework so I can help you understand better how to pick the right option. Some A or B. The other way of saying is there exists at least one A that is B, and the opposite is no A or B. Now let me scroll down. So here I have a simple statement is something that conveys a single idea. It's raining. I like dogs. I ate a cupcake today. Very simple, single idea. A logical connective is a symbol or a word used to connect two or more statements in such a way that the truth value of the resulting sentence only depends on the truth value of the original statements and the meaning of the connectives used. We're going to look at the truth values later into the course. Now let's go ahead and look at a compound statement. Any statement that contains one or more logical connectives. It's raining and I'm drinking coffee. So it's raining, that's one statement, and I'm drinking coffee. It's another statement. So here are the connectives and the symbols. So if you're negating, you use this symbol, right? Not, and the formal name is negation. And is an inverted V, and you call it conjunction. Very important. Or it's a capital V. You call it disjunction. I like pink or blue. I like pink and blue. If, then. So sometimes in some of the books it's represented with one arrow, and I think in this platform or the online homework it's represented with double arrows. It's called conditional. If you give me $1, then I give you a coffee. If and only if. If and only if you did your homework, you would have aced the class. So if and only if. That's a two-way arrow and it's called biconditional. Okay, now let's go ahead and take a look at the homework problems. Let's take a look at this problem here. Some of these numbers are even. Excuse me. They ask me for the negation. So I'm going to go back here and say some, the negation is no A or B, or all A are not B. So I'm looking for the word no, right? So here none, some of these are even numbers. So the opposite is none of these are even numbers. Simple as that, right? Perfect. All right, which one of these sentences is a compound statement? Remember what I talked about compound. Compound statement is something that combines two statements together. So it is false that bats are mammals. That's just one statement. Bats sleep upside down. That's just one statement. If the bat population increases, then the mosquito population decreases. Bats navigate by sound. Out of all these, only this one has a combination of both of them. There you go. Let's look at the example here. Let me just scroll this up. I think I can. Form the negation of the following statement. It is not true that wine in moderation is not good for heart. So here, what they are saying is, let me go ahead and get my pen tool here. This is kind of tricky. It says, it is not true. It is not true that wine in moderation is not good for the heart. Now, you might by default think wine is good for heart, but remember what the sentence is. It is not true. So all I have to say is, it's true that wine in moderation is not good for heart. So technically, wine in moderation is not good for the heart. So don't change the second negation, only change the first negation. All right? I have to click escape so that the annotations will disappear. Oops. So wine in moderation is not good for the heart. There you go. All right, continue. All right, let's look at this problem here. This is very interesting. Determine whether the following sentence is simple statement or a compound statement or neither. If it is a compound, select all logical connectives being used. Otherwise, select none of the above. So I always want to read first. So I'm going to say 4 is less than or 4 is not less than 5. 5 is less than or equal to 3. So if I erase this and I'm going to go back, so here I have the connectives not less than. Do you see that? Not less than. That is this. Or this says 5 is less than or equal to. That's what this symbol means, right? Less than or equal to, not less than. So definitely I have a not. Definitely I have a or, right? 4 is not less than 5 and 5 less than or equal to 3. So I have all 3 of these. So let me go ahead and select those. Not and or. Now let's look at the next one here. It says the following statements are equivalent to, so let's see this here, equivalent to every, I hope I'm saying this right, basicist. Every basicist is a musician. Uh, I okay, I hope I'm saying this right. Every basicist is a musician. So it says every, so I'm thinking all bassicists are musicians. So what's the equivalent for that? There are no bassicists that are not musicians. So no bassicists, not musicians. So you're looking for the equivalent. So they said when equivalent, I actually messed up a question. Instead of reading equivalent, I thought it was negation. I answered negation. So please make sure you don't do a mistake like me. So let me go ahead and erase this. Check no bassist is a musician and then click submit. There you go. All right, the next one. There is at least one book on the subject in the library. There exists at least one A that in B. Again, they're looking for equivalent. So equivalent of there exist is some A or B. So I'm looking for the word some. So some are on the subject. There you go. All right, what is the negation of the statement every rose has a thorn? Choose each correct answer. So I'm looking at every rose has a thorn, and here I say all roses have thorn. Every is all. And the opposite is some A are not B. So let me erase this so you can see that better. So I have every rose. Every rose has a thorn. All A are B. Some A are not B. So some roses do not have a thorn. That's your right answer. Let's look at the last negation problem here. Some curves have spots. So I'm going back here. Some A or B. What's the negation? Not no A or B. That means no curve, no curves, no curves have spots. Am I saying it right? No curves have spots. And what is another way of saying all A are not B? So all curves do not have spots. So you see that? It's this and this. Always have this diagram with you when you're doing negation, because even I tend to get confused sometimes because of the terminology. So I always have to have this diagram when I'm doing it. Now let's go ahead and tackle some of the conjunctions and we should end this session. Determine whether the following statement is compound statement. If it is, then select each of the connectives that I used. So here I have the easiest way to do something like this is read. So 1 is less than 3 and less than or equal to 17. So there you go. I have my connectives right here. So read as you, what do I say? So read as you write. That way you can have your connectors right away. All right, one last problem. The compound statement, which of the following is a compound statement? Again, you're looking for connectors and or, if then, if and only if. So I see that the first thing I see is if and only if. Do you see that? And then I see a or here. And then every time you see if and a comma, so if you see a if, a sentence and a comma, that means if, then. So blindly, this is another connector. This is another connector. This is another compound statement. So there you have it. All right. Again, if you have any questions, please don't hesitate to email me. Reach me through Teams.